welcome back. We will start a new section today, but before, have a look at this question. Try to answer this question. Recently, Orlando Magic beat Washington Wizards with a 10 points advantage, overcoming another triple-double by the opponent. Both teams scored 250 points in total. What was Magic's score? Can you figure it out how to find the answer for this question? Well, think about it and later we get back. We will work on chapter 4 today, Systems of Equations, and section 4.1, Solving Systems of Linear Equations in Two Variables. The first objective is to determine whether an order pair is a solution for a system of equations. A system of equations consists of two or more equations. The solution of a system of two equations in two variables is an order pair, x and y, that makes both equations true. And let's understand this working on an example. Determine whether x equals -3, y equals 1 is a solution of the system. And we have the system here, x minus y equals -4, 2x plus 10y equals 4. You have to plug in the order pair, and let me write here. This is the order pair. You're going to plug in each one of the equations. Let's start with this one. Equation number 1 is x minus y equals -4. So we have to plug in and check if this produces a true statement. X is -3, y is 1, and this is supposed to be -4. Let's check if this is true. -3 minus 1, -4, equals -4. True or false? What do you think? True or false? Yes, this is true. Now let's check equation number 2. And we can use the same screen here. Let's just split in 2. On this side, let's work with 2x plus 10y equals 4. This is equation number 2. Plug in 2 times what? 2 times -3 plus 10 times 1. Is this equals to 4? What do you think? True or false? Is this equals to 4? Let's check. 2 times -3, -6. And 10 times 1, 10. And I don't know yet. Is this equals to 4? -6 plus 10, 4. Equals to 4? Yes, true. This is true. The conclusion here is yes, it is a solution for the system of equation. Great. Now let's move to the next example. Sorry, here. Determine whether x equals 4, y equals 2 is a solution of the system. 2x minus 5y equals -2, 3x plus 4y equals 4. Well, we have to do the same thing, and let's check for each equation. Let's see. Let's split here the screen. I like to work on this side, and this is the system of equations right here. On this side, let's work with 2x minus 5 equals -2. This is equation number 1. And on this side here, we will work with equation number 2. This 3x plus 4y equals 4. Nice. And plug in, check the numbers that we have here. X equals 4, y equals 2. So 2 times x equals 4, 4. minus 5 times what? Y equals 2, equals negative 2. Let's, I still don't know, question mark, I still don't know. 2 times 4, 8, and 5 times 2, 10, excuse me, equals negative 2. I still don't know. 8 minus 10, negative 2, equals negative 2. Yeah, yes, this is true. Check mark. Yes, true. Nice. So that means the order pair x equals 4, y equals 2 is a solution for this equation. Now I have to check the second equation, the other equation, and make sure it is true for both equations. Then we can say is a solution of the system. So check the next one. I can use a different color, this light blue. 3 times what? 4 plus 4 times 2 equals 4. I don't know yet. I don't know if this is true or false. 3 times 4, 12. 4 times 2, 8 equals 4. And it's getting strange. 20 equals 4. Is 20 equals 4? What do you think? Is 20 in any situation going to be equal to 4? No, this is false. That means no, it is not solution for the system of equation. Okay? Needs to be a solution for both equations. You have to try, you have to plug in into both equations, and it needs to produce a true statement for both equations. Okay, next objective, number 2, solving a system by graphing. Since a solution of a system of equations is a solution common to both equations, it is also a point common to the graph of both equations. To find the solution of a system of 2 linear equations, we graph the equations and see where the lines intersect. Let's work on this example here. Solve the system. We have the equation 2x minus y equals 6, and we have another equation, x plus 3y equals 10. Let's build a table here for equation 1. Let's build here. This is going to be for equation 1 with x and y. Okay, and let's build another table here for equation number 2. Let's use this green. Equation number 2. Let's build another table, right? With this is equation number 2, with also x and y. Let's say for equation number 1, if x equals 0, y equals 2 times 0, 0, negative y equals 6, y equals negative 6. Okay? For y equals 0, then 2x equals 6, x equals 3. Let's get another point here, just to have 3 points and be sure we have the right graph. And let's say we make y equals 2. Y equals 2. And then x equals negative 2. Go to the other side, positive 2. X equals 4. Okay? You can do the calculations, check if I did everything right. You can do it in your scratch paper and find out if I worked this right. We have 3 points here for x, for the coordinates x and y for graph number 1. Let's and then go to the rectangular coordinate system and find these points. X equals 0, y equals negative 6. X equals 0, 1, 2, 3, 4, 5, 6. So 1 point is here. X equals 3, y equals 0. X equals 3, 1, 2, 3. Y equals 0, and right here. Oops, another point here. And x equals 4, y equals 2. x equals 4, 1, 2, 3, 4, y equals 2. Oops, right here, right? And then connect the dots, and be careful. You have to use a ruler, something to be precise, and then you will be able to have a neat and nice graph. Now working on graph number 2. Let's say x equals 1, and then we're going to have 3y equals 9, y equals 3. Let's say now x equals, and I try to guess numbers that we're going to find y as an integer, so I'm going to guess here x equals 4. If we have x equals 4, and then 3y equals 6, y equals 2. And if we have, let's say, x equals 7, and then we have y equals 1. Nice, we have nice integer numbers. We can find them in our graph. X equals 1, y equals 4, 1, 1, 2, oops. 1, 2, 3, 4. Right here is the first point. X equals 4, y equals 2. 1, 2, 3, 4. Y equals 2. Oops. Interesting. And x equals 7, y equals 1. 1, 2, 3, 4, 5, 6, 7. And y equals 1. Now we draw the line here, neat and straight. If you have, and I recommend you to use a ruler to try to do the best and cleanest and nicest graph that you can. But by accident, we just found here the intersection, because we have x equals 4, y equals 2, x equals 4, y equals 2, and we can identify here on the graph, this is going to be the intersection point, right? This is the intersection point, and that is how we find the solution, by graphing. We draw the graphs, find the point where they intersect, and then find out the coordinates of the point. X equals 4, y equals 2. After you identify the coordinates, it's very important to be sure that this is the right answer, so you can plug into the equations and check if your answer will produce a true statement for both equations. Yes, although the solution to the system of equations looks like it's x equals 4 and y equals 2, you need to check. You substitute x equals 4, y equals 2 into the equations, and then you're going to have into the first equation 2 times x, oops, 2 times x, and x equals 4, minus 2 equals 8 minus 2, which is equals 6. Yes, this is going to be a true statement, right? And the next one, you substitute into the next equation 4 plus 3 times y equals 2 equals 4 plus 6 equals 10. Also a true statement. That means, yes, the point x equals 4, y equals 2 is a good one. It checks. It is a solution of the system of equations. A helpful hint: if you draw neatly, it can help you when guessing the solution. Use a ruler. Try to do everything as precise as possible to help you out finding the right solution for the system of equations. Okay, we have a new example here, another example. We will graph, and we have the equation negative x plus 3y equals 6. We have the other equation 3x minus 9y equals 9. And we can split here the screen in two. And let's try to find a few values for x and y here, x and y. Let's say x equals 0. Then we will have 3y equals 6, y equals 2. If we make x equals, let's say, 3, x equals 3, negative 3, 3, it goes to the other side, it's going to be 9, 3y equals 9, so y equals 3. And let's also make x equals 6, x equals 6. I'm trying to find integer values that are integers easier to plot on the graph. Negative 6, move to the other side, is 12, 3y equals 12, and then y equals 4. You can check in your scratch paper, you do your calculations, check if I did everything right, and let me know. Now check x and y for this equation here. And think here, for x equals 0, 0, and then we will have negative 9y equals 9, y equals negative 1, right? Now for x equals 1, no, not 1, let's try something different here. For x equals 3, x equals 3, if you have x equals 3, 9, y equals 0, y equals 0. Cool. And now let's try x equals maybe negative 3. Yeah, negative 3. Negative 3, negative 3, negative 9, and 18. 18 divided by negative 9 is negative 2. Well, we have here 3 points for each graph. Let's go and plot these points. Okay, I copied the points that we found here, so we can draw the graphs. For equation number 1, x equals 0, y equals 2. So x equals 0, y equals 1, 2. That's the first point. For x equals 3, y equals 3. So 1, 2, 3. 1, 2, 3. Okay, here, another point. And x equals 6, y equals 4. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. Try, yes, you need to have a ruler. I don't have a ruler here. Maybe my line is not going to be so nice, but I suggest you try with a ruler and try to do as precise as you can. Now moving to equation number 2. The graph is, the points are x equals 0, y equals negative 1, 0, y equals negative 1. Oh, right here. The other point is x equals 3, y equals 0. So x equals 3, 1, 2, 3, y equals 0. There's another point here. And x equals negative 3, y equals negative 2. 1, 2, 3, 1, 2. Nice. This is going to be, and look at that. It looks like the graph, the lines, they are parallel, right? If they are parallel, what's going to happen is that they never going to have an intersection. They will never intersect each other. There's no common points. And if we don't have a common point, there will be no solution. And another way of confirming that they are, there is no solution, that the lines are parallel, is to, let's go back a little bit, to change each equation and transform as using the slope intersect form. So we can change, let's say, equation number 1, and we're going to move everything to the other side of the equation, keep just y on the left hand side. We will apply addition property of equality, add x on both sides, So we can get rid of this x. We have 3y equals x plus 6. And then divide both sides by 3. And if we divide both sides by 3, or multiply by 1 over 3, and we will have y equals 1 over 3x plus 2. This is equation number 1. Check equation number 2. We can do the same thing, transform, change the form of the equation, and write it using the slope-intersect form. Applies addition property of equality, subtract 3x on both sides, and then we have negative 9y equals negative 3x plus 9, and we can divide both sides by 1, multiply or both sides by negative 1 over 9, or divide both sides by negative 9, same thing, right? 1 over negative 9, okay, and simplify here, so y equals negative 3 divided by negative 9, 1 over 3, x, and negative 9 divided by negative 9, I mean positive 9 divided by negative 9, negative 1. Check, compare the equations. What do you see that they have in common? What can you identify that they have in common? Yes, look at that. This slope m is the same, and this is a confirmation that they are parallel. If they have the same slope, they are parallel. And also they have different y-intercepts. Remember, this is the y-intercept. B is the y-intercept, so they are parallel. Let's check another example. We have here, solve the system of equations by graphing. And we have x equals 3y minus 1, and 2x minus 6y equals negative 2. So let's try to solve it. Make here the table with x and y, and if, let's say, if x equals 0, we will have y equals 1 over 3. 1 over 3. If x equals, let's use another number here, let's say 2, then we're going to have x equals 2, y equals 1, and if x equals, let's say 5, x equals 5, then y equals 2. Check if my calculations are right. Get your scratch paper and check if the numbers that I found are right. Now we're going to find the x and y for this equation here. 2x minus 6y equals negative 2. Let's say x equals 0. X equals 0. Then we're going to have y equals negative 2 over negative 6, 1 over 3. Okay. If x equals, now let's say x equals 2, 4, negative 6 over negative 6, 1. And if we try x equals 5, 2 times 5, 10, and negative 12 divided by negative 6, 2. So 5, 2. And this is pretty interesting. Check this out. They have the same points. It looks like they are coincident. They are on the same place, the same position, right? X equals 0, y equals 1 over 3. Here, x equals 2, y equals 1. And the other point is x equals 5, y equals 2. X equals 5, y equals 2. So we have 3 points. We can connect the points. This is one line. The other line is going to be on the same points, crossing the same points, on the same place, the same spot. They are coincidence. See? And when something like that happens, that means all the points, the whole line will intersect. All the points are solution to the system of equations. we will have infinite solutions for this system of equations. And on this example, we can kind of be sure because we checked the same points, right? We can see that they are really coincident. But if we have another situation we are not sure, then check by transforming the equation into the slope-intercept form and compare the slope, compare the y-intercept, and you will be 100% sure if they are identical. Any order pair that is the solution of one equation is also the solution for the other equation. That means the system has an infinite number of solutions. Now we have seen a few examples. We can come to a few conclusions. Check this out. There are three possible outcomes when graphing two linear equations in a plane. You can have one point of intersection, one and only one point, and then you're going to have just one solution. The other situation is if they are parallel. If you find parallel lines, then you're going to say, yes, this has no intersection, this system has no solution. And the third situation is this: if the lines are one on top of the other, they are coincidents. That means you're going to have infinite number of solutions. All the points of each line are a solution for the system of equations. If there is at least one solution, the system is considered to be consistent. This is a name that's given to the system. And if the system defines distinct lines, the equations are independent. If they don't have solution, they are parallel lines, they are independent. And this graph summarizes the conclusion that we just talked about. Check this out. Possible outcomes: one solution, that's a consistent system, independent equations. No solutions, inconsistent system, independent equations, and infinite number of solutions is a consistent system, independent equations. Now, objective number 3, solving a system by substitution. Another method, we learned how to solve a system by graphing. Another method is the substitution method. To use the substitution method, we first need an equation solved for one of its variables. Then substitute the new expression for the variable into the other equation and solve for the other variable. And check how we do this in this example. We have here two equations, 2x plus 3y equals 13, and we have x equals y plus 4. We have one of the equations is solved for the variable x as a function of y. See? So we can just plug in this x into the first equation, this x here, can substitute. So let's get this first equation, 2x plus 3y equals 13, okay? And let me just fix this, equals, nice. Now we will change x here, and we will use the second equation, y plus 4 instead of x. So 2 times what? Y plus 4. And then we repeat everything here, plus 3y equals 13. The next steps are just simplification. You apply addition property, multiplication property. The first thing to do is apply distributive property here and solve for y. 2y plus 8 plus 3y equals 13. Combine like terms, 5y plus 8 equals 13. And then apply addition property, subtract 8 on both sides, and then after that you divide by 5. Well, at the end, you will have as a solution here, y equals 1. After you apply addition property of equality, multiplication property of equality, and simplify, have only y on one side of the equation, you're going to find the solution to be y equals 1. Now we know the y value of the order pair, which is 1. To find the x value, we will replace 1 in the second equation, or any equation to be honest. But the best way is to substitute in the second equation. X equals y plus 4. And x equals y plus 4 is x equals 1 plus 4 equals 5. The solution is x equals 5, y equals 1, right? The check, you can check, you just plug in these values back into the system just to make sure, to be completely 100% sure that they are the solution of the system of equations. Step by step for the substitution method. Step number 1, solve one of the equations for one of its variables. Step number 2, substitute the expression for the variable found in step 1. Step 3, find the value of one variable by solving the equation from step 2. And step 4, find the value of the other variable by substituting the value found in step 3 into the equation from step 1. And step 5, check the order pair solution in both original equations. Now, objective 4, solve a system of equations using elimination. That's another method. We learned graphing, we learned substitution. Now we're going to learn system to apply the elimination method on a system of equations. Another method is called elimination or addition method. The addition method is based on the addition property of equality. Adding equal quantities on both sides of an equation results in an equivalent equation. And it's very simple. Check this example here and see how simple it is. Look, we have equation x plus y equals 7. We have equation x minus y equals 9. We will add both equations, and then we add x with x to x. We add positive y with negative y, 0. We add 7 and 9, 16. Now we just have to divide both sides by 2, and then the answer is x equals 8, right? We can do this. The objective is, after you add, you're going to eliminate one of the variables and keep just the other one, or the other variable, to be able to simplify and find the answer for this variable. Now you plug in into the equation. Let's say you can plug in into any the first or the second one. Let's say the first one, x plus y equals 7, right? So you can plug in 8 plus y equals 7, and then you find that y equals negative 1. Step by step for the elimination method, you can see here. Rewrite each equation in the standard form, ax plus by equals c. If necessary, multiply one or both equations by a non-zero number so that the coefficient of the variables are opposite of each other, so you can eliminate. Add the equations. Step number 3, add the equations. Step 4, find the value of one variable by solving the equation from step 3. Step 5, find the value of the second variable by substituting the value found in step 4 into either of the original equations. The first or the second one, doesn't matter. And step 6, check the proposed order pair solutions in both original equations. Let's try another example here. Solve the system of equations using the elimination method. And check, we have some fractions. I know you get a little scared when you see fractions, right? Oh no, fractions! Don't worry, we will simplify. The first step is to simplify and to try to avoid working with fractions. And the best way is to find, let's find here the lowest common denominator, so we can eliminate all the fractions. We have 3, we have 4, we have 2. So the lowest common denominator, 3, 4, and 2 is going to be 12, right? If you don't remember how to find the lowest common denominator, we can have a quick reminder here. You check the first one, is the first is 3 exponent 1, the second denominator I have here is 2 exponent 2, right? And the third is 2, is just 2 exponent 1. You get the each base that you find. So you have base 2, okay, base 2, we have base 3, and you get the largest exponent, the greatest exponent, exponent 2 and exponent 1. So the lowest common denominator is going to be 2 exponent 2 times 3 exponent 1, 12. Okay, this is just a quick review on how to find the lowest common denominator. Let me erase this so we don't get confused here. Multiply by 12. Both sides here and this side as well. And then we will have as a result 12 times 2, 24, divided by 3, 8, 8x. 12 times 1, 12, divided by 3, by 4, I mean 3, y, equals negative 3 times 12, negative 36, divided by 2, negative 18. Right? Now the second one, apply distributive property here, 12 times 1, 12 divided by 2, 6. 12 times negative 1, negative 6. Negative 12 divided by 4, negative 3. Sorry. And negative 2 times 12, negative 24. Great. Check this out. We can, we have, if you look at those equations, you're going to see that y have the same number as the coefficient, but with opposite signs. That means after we add, we will simplify. Positive 3y minus 3y, 0. And that's the objective, because we're going to have an equation here, a result only with x. 8 plus 6, 14. X equals negative 18 minus 24, negative, and this is going to be negative 42. Right? Negative 42. Divides negative 42 by 14, and you're going to find the answer. You're going to have x equals negative 3. Right? Plugging into one of the equations, the first one or the second one, doesn't matter. Let's plug in into the, let's say the first one. 8 times x plus 3y equals negative 18. So we plug in 8 times negative 3. 8 times negative 3. Sorry. Plus 3y equals negative 18. After you simplify, you're going to apply here addition property. 8 times negative 3, negative 24. And if you move to the other side, negative 24 is going to be 6, positive 6. 3y equals 6. Y equals 6 divided by 3, y equals 2. This is the answer. This is the order pair that makes this this system, that's a solution for the system. X equals 3 and y equals 2. Negative 3, I mean. Negative 3 and y equals 2. Now let's work with another example. We have x minus 3y equals negative 2 and negative 3x plus 9y equals 5. And yes, this is interesting because look what's going to happen. We can multiply, we check, we don't have the same coefficient for at least one of the variables, right? So we need to multiply one of the equations by a number to make possible that after we add the equations we can eliminate one of the variables. And I think we can multiply maybe by 3. We can multiply by 3, the first one. Let's do this. 3x minus, so multiply by 3 here, multiply by 3 here, 3 times x, 3x, negative 3y times 3, negative 9y, and negative 2 times 3, negative 6. Cool. Now we have the other equation, negative 3x plus 9y equals 5. Well, we can add, check what's going to happen if after we add, and then we're going to simplify 3x with negative 3x, negative 9y with positive 9y, and this is going to be 0. And on the other side we have negative 6 plus 5, negative 1. What do you think about it? Is this true or false? This is definitely false. This is wrong. That means this is a situation where there's no solution. There's no solution because the equations, they are parallel. It's a situation where there's no intersection. The equations, both lines, they don't have a point that intersect, the common points, and we will have as a result a false statement. So no solution. And there's another example here. Let's try this one. See if we can do elimination method again, and maybe we can multiply one of the equations by a number, and definitely we can multiply the first one by 2. Let's multiply the first equation by 2 and try to apply elimination method. If we multiply 2 times 2x, 4x, 2 times 5y, 10y, and 2 times 1, 2, the next equation, negative 4x minus 10y equals negative 2. Look how interesting. Look here what happens. 4x minus 4x, 0, 10x minus 10x, 0, 2 minus 2, 0, 0 equals 0. Is this true or false? This always will be true, no matter the value of x, no matter the value of y. And this is an example of coincident lines. If you check the graph of these lines here, you're going to see they are coincidents. They are one on top of the other. The equations are the same, and it has infinite solutions, infinitely many solutions. Infinite solutions, okay? And let's check if If we have another example, solve this system now. Another example, 4x plus 5y equals 14, 3x minus 2y equals -1. And we have a new example now, solve the system, 4x plus 5y equals 14, 3x minus 2y equals -1. We don't have any coefficients of variables that are the same, that are coincident, that we can eliminate. So we need to multiply one or both equations by a number that will make this happen, will make the coefficient the same. Let's say we multiply the first equation here by 2, and we multiply the second equation here by 5. The whole thing, the whole equation. Multiplying this first one by 2, we have 8x plus 10y equals 28. Okay? And multiplying the second one by 5, then we have by 5, 15x minus 10y equals -5. Okay? Now we can add the equations, and 8x plus 15x is 23x. We eliminate this, positive 10y minus 10y 0, and 28 minus 5, 23. Cool, because we can see that x equals 1. This is a solution for x. Now we're plugging into the first or the second, doesn't matter. Let's plug in into the second, the first, 8x plus 10y equals 28. 8 times 1 plus 10y equals 28. Well, 8 times 1, 8. This makes 20. 10y equals 20. Y equals 2. After you apply addition property, multiplication property of equality, simplify, you're going to find y equals 2. And the solution set for this system of equations is x equals 1 and y equals 2. Check plugging the numbers into each equation and make sure that this produces a true statement for each one of the equations, and then you're going to check this is the right solution for that example. Okay, now we're finished. This is the end of section 4.1. And how do you think about solving this? It's not a puzzle, it's kind of a question. If Orlando Magic beat Washington Wizards with a 10-point advantage, and both teams scored 250 points in total, can you find out the Magic's score, the winner's score? And I think so. Let's try. And we can make here, we can apply the knowledge that we just got from system of linear equations. We say x plus y. Let's say x is the score of Magic, Orlando Magic, and y is the score of Washington Wizards, right? If you add the scores, you know it's 250 points, right? 250 points. But you also know that if you subtract the score of the Orlando Magic that won the match by the score of Wizards, you have 10 points, right? Look at that. This is a system of linear equations. You can add, apply elimination method here. X plus x, 2x, positive y minus y 0, and 250 plus 10, 260. 2x equals 260. Divide both sides here by 2, and you find the score to be 130 points. The score of Orlando Magic was 130 points. Thank you for watching this video. Have a good day, and hope to see you back soon. Bye bye.